Okay, so this video is a continuation of motion, so I guess we're going to call this thing, I think, motion packet part 2 or something like that. Motion packet part 2. That's the name of this video. And we're on 357 in this packet, and we're looking at a position function. We're trying to figure out what's going on with the motion. So here's the position function. So we'll start there. So maybe for starters, we'll say green, like that's where you start, right? And this is the beginning. And then we need to derive that. So what's happening is we're deriving that to get the velocity. So that's our next step. So pretty simple. We derive this term, this term, this term, this term. We get 6t squared minus 42t plus 60. And we can factor it if we like. So either of these are fine for the velocity function. So that's how the particle's velocity is going to be. How fast it is, you can just plug in a number to that, either of those velocity functions. To get the acceleration, we derive the velocity. And this is kind of a new-ish thing, and we'll make that red, I guess, because it's going to be like the final step. So you can, of course, use either the left or the right here. We usually like to derive with the left and then usually put it into factored form when we're setting it to 0. So the factored form might be helpful later, but for right now, just taking the polynomial form is good. So now we need to figure out where the thing's going. So what we're going to do is we're going to do a couple of number lines. This is how we're going to figure out whether the particle is speeding up or slowing down. By looking at the velocity and the acceleration. If they're working together, then it's speeding up. If they're working against each other, it's slowing down. So if you notice here, you see this factored form in the blue. What we'll notice is that if you set this to 0, 6t minus 2 and t minus 5 is equal to 0, you'll have that the object is stopped at what time? The velocity is 0. The object is stopped at 2 and at 5 seconds. So those numbers are then put onto our velocity sign. So this is our velocity number line, which is our first derivative number line, by the way. And that's why we have the number 2 and the number 5 there. Okay. So now we're analyzing based on this number line, which is very similar, increasing, decreasing. Increasing means the object is going up, right? And decreasing means the object is going down, in a sense, in this case, with velocity. So when we have positive velocity, we're moving in the positive direction. That's here. We're moving in the negative direction from 2 to 5. We just plug in a number to like 3 or whatever, right, into the velocity, the blue. So everything here is all about blue, okay? It's all about the blue function. And that tells us what we're doing. The object's going up, then the object's going down, then the object's going up. That's seemingly what's happening. When is the particle stopped? At 2 and 5, because that's when the velocity is 0. Because how do we get the numbers? By setting to 0. So that's obviously when the particle is stopped. Now we're going to look at the acceleration, and then we're going to put it all together in a moment. So this is the velocity, and this is the acceleration line. Hold on a second. This is not it yet. Interesting. Okay, here we go. Good. So this is the acceleration number line. Let me just kind of break this down a little bit for you. We had the acceleration up above to be as follows. Let's see. 12t minus 42. So I'm copying that from above. 12t minus 42. Okay. So if you take that 12t minus 42 and you set it equal to 0, I guess you could divide both sides by 6, I think. Which would give you, can't divide by 12, no. So if you divide by both sides by 6, you get 2t minus 7 equals 0. So this is an acceleration of 0 at 7 over 2. So that number goes onto our acceleration number line, okay? So this 7 over 2 is on our acceleration number line. I want to take a second to kind of just block this out. This is our velocity number line. We're going to care about this in a minute, but right now we don't care about it. So I don't want it to confuse you, so I've just scribbled it out completely. Looking at everything red, not blue, because I scribbled it out, you can put in a number into velocity, like let's say 1, for example. Acceleration. You can put a number like let's say 1 into acceleration, and you'll get that the acceleration is negative. If you put 1 here, right, if you put 1 into this, you'll find that it comes out negative. So acceleration is negative this whole time. Sometimes we just put one giant negative sign, but they put a whole bunch of them for a reason, and I'll show you in a second. So hopefully the blue number line also makes sense. So we have the blue number line and the red number line. And hopefully they're all good to go. So now we're going to talk about what this means. So give me 1 second to kind of get you through this here. I'm going to cover up one more thing. Dang. Okay. Struggle today here. Okay, good. So now let's erase this and kind of just break it down. We have two number lines here. We have the blue number line, which is the velocity number line. So this number line right here, blue number line, which is the velocity number line. And then we had the red number line, which is the acceleration number line, which is right here. Okay. And there's that. Now, I don't want to make this graphic too confusing, but if we look at this for a second, we can find out that there's a couple of things that matter. Obviously, the time 0 matters, so this time right here matters. Obviously, time 2 matters because it's critical for our velocity. And acceleration at 7/2 is an important time. And actually 5 is another important time. And then it just goes on forever and ever and ever. So look in between those dotted lines and tell me when the object is speeding up or slowing down. From 0 to 2, the first interval, are the velocity and the acceleration working together or against each other? Are they working together or against each other? They are working against each other. Velocity is positive, acceleration is negative, so the particle is slowing down. Okay? Now the particle stopped. We talked about that earlier. What's happening here from 2 to 7/2? Are they working together or against each other? Together. It's going down and it's being pulled down. It's like an apple falling from the sky, moving down, but gravity is also pulling it down, so it goes faster and faster and faster until it hits the ground. Starts out slow and then it gets faster and faster and faster. So speeding up. A lot of people think when acceleration is negative, it means it's slowing down automatically. Not true. Acceleration is negative does not mean something's slowing down, necessarily. Okay, working together or against each other from 7/2 to 5. Against each other, so slowing down. Perfect. Very good. And then what happens? The particle stops again, and then they're working together, speeding up. So you can kind of see what's happening here in this general understanding here. And they did put particle stop, particle stop. They didn't say what was happening here, 7/2. What do you think 7/2 is if we look at that for a second? Hold on a second. I want to try something. Do this once again and see if it works out better. What do you think is happening here at 7/2? I know the dotted lines don't help matters. But at 7/2, this is the acceleration, right? Which is the derivative of velocity. So this is the velocity derivative graph. Agree? So would that be representing a maximum or a minimum? And would it be a maximum or a minimum of what? I mean, is it a max or a min, this layout here? It's a minimum, yes? Something went down and then went up. Something went like this. Is it a minimum of position, velocity, or acceleration? It's a minimum of velocity. So that's the slowest. It's a local minimum, I guess, but it's a local min for velocity. Because we took velocity's derivative, which is acceleration, and then analyzed it. So the original of this was velocity. So this is velocity at minimum, a minimum velocity there of some sort. Okay, cool. So that's kind of what we need to talk about, speeding up and slowing down. That's the big picture. Here's another one that I kind of like to understand. This right here. It kind of talks about what's happening. So hopefully you have all that other stuff in front of you. Here's what's going on, okay? We know that the velocity is, at first, the velocity is positive. So we're going this way, and velocity is positive, right? And it's positive all the way until t equals 2. So we can kind of see that it's positive all the way until it gets to here, t equals 2 right there. Interesting technique. So positive until t equals 2, yeah? Good. So we got that. And then it turns around. So we actually know that the velocity, which we've been using blue for, is now negative. And it's negative all the way until t is equal to 5. So we notice that the velocity is negative until we get to t is equal to 5 right here, which is pretty good. And then the velocity becomes positive again after that. So the velocity is actually, it turns around and it goes this way again, and velocity is positive. So velocity is positive, negative, positive. positive up until 2, then negative till 5, and then positive again. That's what's happening there. It's kind of cool to see like what happened in this diagram. The object like went along, then turned around, and then it turned around again. Okay. Very good.